everyone to this session on advanced Spring Data REST. I was surprised they pick an advanced session without picking any kind of introduction in the first place, but it is what it is, so we have to deal with that. My name is Oliver Gierke. I work for a company called Pivotal. Has anyone ever heard of Pivotal? Okay, that's getting better over the years. It's mostly because of not because everyone has to know about the company, but after the Spring Source VMware Pivotal transition, a lot of people lost track of what that company actually is, what it's doing. I'm part of the Spring engineering team leading the Spring Data project, which means that everything that's sort of data related and not taken care of by the core framework and is like ordinary the Java APIs for data access is basically on my team's desk, which means we're building APIs for relational and non-relational databases for you to access data easily, right? And try to come up with some kind of programming model that the knowledge that you gained working with it is easily transferable, something that you find in other areas of the Spring framework too. And it turns out that there's one special project in that umbrella project. So I guess, who of you has never used Spring Data before? Oh, only very few hands. That's good, because then you probably, if you're familiar with Spring Data in general, then you know it's an umbrella project consisting of individual modules for different stores, for, let's say, MongoDB, for JPA, for Neo4j, for Couchbase, Cassandra, Elasticsearch, Solr, yada, yada, yada. And there's one module that sticks a bit out of that kind of the set of modules that support individual stores, which is the data REST module. It was coined around about 2 years ago, where we thought, okay, there is this repositories programming model that you have with Spring Data, and we've seen people doing the same things over and over again on top of these repositories, which was building RESTful APIs or trying to build RESTful web APIs, although some of them get stuck in HTTP and JSON, and that's it, right? So that thing became quite popular, and this talk is actually about some advanced concepts in it, or basically taking a look over the fence of what the project actually is and see, okay, how can we apply it to advanced use cases, and how can we extend it, how can we customize it, and what are the usual patterns that we see there, right? I've also highlighted a sample project that we've created to show you the more advanced scenarios. This is called Spring REST Bugs. We'll get to that in a second. It's basically taken, the domain that's implemented in there is taken from a book called RESTful Web Services by O'Reilly. In case you haven't read it before, highly recommend it. There's a Starbucks kind of shopping experience, like you order coffee and then the order is processed in the back, and then you eventually conclude the order. There's a process in there. The original book implements that using JAX-RS and just like a bit of glue code for the hypermedia aspects of the REST web service. And it's been quite a while ago when I thought, okay, that might actually be a neat showcase for how to do that or implement the same scenario with the Spring Stack. And then along came Boot, and along came Spring Data REST, and it basically just allowed me to throw away more code, which is kind of nice. And it's kind of a poster child example of, okay, how do you integrate Spring Data REST with custom logic, with more advanced logic, how to make use of hypermedia and the benefits that it actually provides for RESTful web services. So I'd like to start with one thing, because who of you has used Spring Data REST before? That's probably a good question. Okay, that's not even half of the audience. Okay, so I probably let me dive into the 5-minute elevator pitch for what Spring Data REST does before we actually come to the next section, which I actually wanted to start with. But if we have an audience here that is not entirely familiar with it, then it might help just to understand what I'm trying to get to with that section beforehand. So I'll start with a pretty simple example, just to give you the gist of it. I found a CSV file on the internet containing all Starbucks shops in Northern America at some point in time. It's 11,000 Starbucks shops, I think, so it's got to be like 10 years ago or something. And it contains all the data, or basically all the shops, as I said, with their geolocation information, right? And I thought, wouldn't it be cool if there was some kind of web service or just like RESTful API that allows you to actually search those stores based on your current location, right? Think of it as an around me kind of implementation. Where is the next Starbucks store, right? And what I do to actually implement that is I create a model class, and we will talk about like domain models a bit in this talk. But here's a very simple one, because I'm not really into modeling a domain here, because it's a very simple thing, right? We just have stores. The stores have a name and an address, and the address has a bit of information and also a location, right? That's a Spring Data MongoDB specific thing here, but I chose MongoDB here because the support for geospatial queries is pretty sophisticated here. It's pretty easy to implement those. So I have these classes. There's a bit of code using parts of a Spring Batch to just like read the CSV file, map the data onto the objects, and then store them into the repository. That's not very advanced, or if you've seen Spring Data before, that's probably not that interesting here. What you see here is a Spring Data repository, which, as you probably can see, is a standard Spring Data extends the Spring Data interface. We extend, that's already something you should have a look at, the paging and sorting repository, because we will want to use the pagination support of Spring Data in our RESTful Web API as well. And then we declare a query method here that basically is all we need to do to actually create the geospatial query, right? So we use the query derivation mechanism saying find by address location near, which then, as probably if you're familiar with Spring Data, is basically translated into the appropriate MongoDB query by translating the method name and then eventually seeing that there's a near keyword and binding the parameters given here to the query when the method is called, right? So if that already troubles you, then I'd suggest to look up the example. The details of how that works are not necessarily important for what we're going to talk about. So far, this is just a basic Spring Data repository with two entities. And what I've done to the project is I've added the Spring Data REST library, right? There should be it's a REST Spring Data REST module here. The Hell browser, we get back to that in a second, but it's basically pulling in the Spring Data REST pieces. So if I now start this thing, Java application. If I now run this thing, the CSV file, we use an embedded MongoDB. The CSV file will get imported so that we have these, as you can see in the log, these 11K stores imported into the database, and we actually get to something like this. That's a funny web front end in front of it, just to visualize what's possible with that thing. So it's just I used all my UI skills, literally all of them, to actually come up with something like this here. What it's doing, there's a Spring MVC controller that's just like basically powering this form here, and we then use a piece of API that we're going to look at in a second to actually build this kind of, use some JavaScript to load the results and then put these markers on that map, right? It's nothing fancy. So if I use a command line client here and pull that up for you a bit and say HTTP 8080/API, we get to something like this. What was it? Accept application help plus JSON. That should do the trick, right? So we see there's some JavaScript or some JSON coming back that has, or some JSON document that exposes some links. So the first of all, what you see here is a format called HAL, hypertext or hypermedia application language. It's basically a tiny specification that defines how links are represented in JSON. It's not the only format out there that does that, but it's a very simple one, right? There's a lot of others like collection JSON, Siren, Hydra, JSON API, JSON LD, whatnot. They are much more complicated and not complicated. They are like more extensive in what they're trying to do, but what hell basically says, okay, there's a links property, and we find an object under that, and then there's like named links that have href values and pointing to something. So how does that stores thing end up here in the first place? Well, as you can probably guess, it's because of our stores repository, right? So we can actually go ahead and follow that link to get a list of stores. Surprise, surprise, right? So the fact that we've exposed that repository to Spring Data REST, and there's of course like configuration where you can tweak which repository is supposed to be exported or not. You see that we get the results here. There's like the address is embedded, there is the location information in here, and the most important thing actually is what you see down here is a different set of links, right? And because of the fact that we had the, where was it? The repository was a paging and sorting repository. Spring Data REST actually leverages that trait really of the repository to not return all the 11,000 stores, which would be ridiculous here because we would just create a JSON with all the stores here. But it limits it to 20 by default, again configurable, and then provides some links with well-known link relations. This is not stuff that we made up, but there's like the IANA link registry, basically a set of predefined link relation names with like semantics defined for them, right? So there's basically some official resource that says, okay, whenever you find a next link, you can follow that thing and you find the next page of a paginated collection, basically, right? And a client that's aware of that semantic can then actually use that and like by that follow the links and actually go ahead and traverse the collection really. So it's stuff that we get out of the box. Another thing that I want to get to is the search resource. It's a resource that we expose and we go ahead and inspect all the Spring Data repositories for query methods, and those query methods get exposed by you see here, there's a by location link. You've probably seen that in the code. There is an annotation to customize what the name of that thing is. We're not too concerned about URIs really. Whether there's a find by in there shouldn't actually matter. Unfortunately, to some clients that does, but a good REST client is like looking up links and links by their name. And that could be just like an arbitrary hash or a foobar or whatnot. If you want, you can, of course, go ahead and customize that as well. Just the very same annotation, but I just use that to make sure this is the thing that matters. All right, so we of course get support for creating new stores through the API. We get support for deleting stores for that API. So you basically get your domain model inspected, and then actually that domain model translated into a resource model, basically, and Spring Data REST doing the right thing, TM, right? So if I show that to people, that the reaction I usually get is, okay, this basically means you have your database exposed to the web, right? You basically, if it's JPA, let's say, you take the columns of your table, flip them by 90 degrees, and then call this thing JSON, and then you basically have a database exposed. Actually, that's not what we're doing here, really. I mean, it sort of is, but it's also not. And the reason I think it's not is that you can't get to, I mean, for that stores thing, you'd probably get to the same resource model with just looking at the table. But if it comes to more advanced use cases, I mean, we haven't seen like a relationship between two entities or resources modeled, really, right? There was only the embedded thing, the address was there, but there was not like an order that was placed by a customer, and these things maybe having two completely different life cycles. And actually, that's something that Spring Data REST looks at very intensively, because if you haven't been to domain-driven design yet, it's quite important to make sure that you understand which kind of role your classes and what JPA just calls entities, and I get back to that fact in a second. What different roles they actually have, right? So what we take is we take your domain model implementation and try to find out which, for very important concept, which of the entities you have are actually aggregate roots, and then apply some REST API patterns on top of those. That's basically what Spring Data REST is, right? So the thing is that I'd argue that from a database model alone, we couldn't go ahead and just derive what we do, period, right? It needs a domain model, it needs additional information, it needs information about what are value objects, what are aggregates and whatnot, so the DDD aspect is coming in quite significantly. And then we're actually doing, I'd argue, in some cases, the better thing that you might do in the first place, or something that might be very cumbersome to implement yourself if you had to do it all on your own. So the idea is, and the question then comes up, okay, why do you actually do that? The idea is that we take care of like all the boring boilerplate parts that might make up a REST API, and not because we think that all the boilerplate parts or the boilerplate parts are the thing that a REST API should consist of, because that's just the easiest thing to do, right? But because we want you to be able to spend more time to actually think about the tricky parts, the interesting parts, right? Are there any custom state transitions that I want to expose through a link, right? Is there any functionality? How can I use hypermedia for the more advanced stuff and whatnot? So it's basically, we're getting to a picture that looks more like this, right? We take care of all the boring part, and you probably have to think about, okay, do I really want to allow like a store to be deleted? Well, if not, then I actually go ahead and configure Spring Data REST that way. There's just a decent default, I think, and we will take care of all the simple stuff, and you should have more time to think about the tricky things. Yeah, I think if we come to the end to the RESTbugs example, I guess that kind of graphic here does make a lot more sense. All right, so for the rest of the presentation, I basically try to stick to code samples and demos only, and we just like go through them. You find a lot of them in the Spring Data examples repository. There's a canonical repository where basically we have all our examples. They're usually very focused on a very particular aspect of whatever Spring Data module you're looking at. And then there is this kind of combined thing, Spring RESTbugs in my personal GitHub for like a combination of different things where it's kind of cool to see that all of that in action, in combination, but it's a bit harder to digest which part is actually, like which piece of code is now actually causing what in the API, right? So we've done that before, so I can skip that. The first thing I'd like to look at is a concept called projections. So let's have a look at a slightly more complex example here, because admittedly, having a store class and an address embedded in it, and then like being able to manipulate those via HTTP is very simple, right? So let's get to a more complex example, hopefully not more complicated. So let me try to just run this thing and then walk you through it. What we have here is an order system, kind of. We basically have customers. We have orders, and the orders consist of line items, right? So this is kind of this thing here: order, line item, customer, and I have put the country into the order because let's think of this as the destination for where to ship that order in the end. We'll get back to that in a second, but let's concentrate on the order customer thing here. I've used JPA here to basically make a point or to reiterate on the point I made before, that the order is an entity, the line item is an entity, and the customer is an entity, right? So to JPA on the entity manager level, they are all the same. They are basically just like tables in the database. However, to the model, they are actually not. Why not? Because there is the relationship between the order and the line items is a completely different one than between the order and the customer, right? The order line items is the line items actually belong to the aggregate of the order, where order is the aggregate root basically, which means that I can't just arbitrarily add new line items to my database. I have to add them through the order class so that the order can actually go ahead and maybe make sure that there's a minimum total amount satisfied or whatnot, basically to implement business rules here. There's also a severe indication that this is the case is basically the way we try to map this thing here, right? The line item lifecycle is completely controlled by the order. If I delete an order, I also delete all line items. That's fine. If I delete the order, I don't necessarily want to delete the customer, would I? So what this, I mean, the thing that you can see this on most, and that's actually the fact that Spring Data REST uses, is that if you look closely here, there's only certain entities that we actually have repositories for, right? We have an order repository. We don't have a line item repository. That should be an indicator for something. And there's like a customer repository, and we have a country repository. Go back into that in a second, right? So the fact, and that's basically a fundamental thing you have to understand, the fact that you have a repository in place for a certain entity sort of turns that entity into an aggregate root to Spring Data REST. It, of course, doesn't necessarily mean that, I mean, there's nothing we can do to prevent you from doing the wrong things, but we sort of expect you to treat these things in your code like an aggregate root and not actually manipulate line items around the order or what have you. So let's have a look at what that stuff looks like on the API level. As expected, we have three links showing up this time, right? So we have the customers, we have the orders, we have the countries. Let's have a look at the customers are pretty much looking the same way that they did before, right? So we have basically a list here. That's the HAL way of saying we have a list of something is this underscore embedded with a named collection, right? So that they can basically make a connection to the type of the resource. And there's a self link in the customer so that we can go ahead and just access the customer directly, right? So that's basically what we've seen with the store. Let's have a look at the order. Yada yada, this way. Zoom out. I can just like zoom in here. That's probably easier. So with the order, we have a single order here. Is that visible? Yeah. Okay. So the shades. I mean, it contains the list of line items. They are embedded, but you see here that the customer is now not embedded anymore. Right? It's pointed to, and actually we expose a dedicated resource for that. Like the underneath order/1, there's a dedicated resource to manage the relationship to the other aggregate root. That's quite an important thing. If you just went ahead and used like Jackson or whatnot to load an order instance and then say, Jackson, please render that thing, it would just render the entire object tree because Jackson itself has no knowledge about a relationship to an aggregate root or to another aggregate root. With Spring Data, when inspecting the repositories, we actually have, and we can do these things here, because what that actually means is that we can draw a line, or we can detect the borders of the aggregate root, and actually shape your representations, your JavaScript or your JSON representations in that way here, right? So it basically preventing the entire database from assume that the customer again has relationships to other things, then that would just like blow up your JSON representation. Also, that kind of look at the domain model is very much driven from the update side of things. So when I want to put or issue a put request on an individual order, let's go look at that. I usually don't want to manipulate the customer at the same time, right? I don't want to change the customer's name, or even if they basically have independent life cycles. The reason that they are different, separate aggregate roots in the first place. All right, so that gives us a decent model for updates, for patch requests, for conditional gets, for conditional puts, what have you. The thing is that we run into a problem here, right? assume a master detail view where we want to show all the orders. And that master view basically is supposed to include the name of the customer. What will we create with that kind of thing here? Basically the n+1 selects problem transferred into the HTTP world, where it's probably much worse, right? It's because additional requests. So for each entry in the order, we'd have to follow that bloody link here and then see, okay, this guy is called Dave Matthews, and then we can just like show that thing and what have you. So we actually might run into situations for reading purposes. We'd need another view on the data. So how do you actually do that? The first thing is that you create a so-called, what we call Spring Data projection, a projection interface, which is, as you probably know by now, that Spring Data loves interfaces. You create an interface that just like declares the properties that you wanna expose. That could be just like the same properties as they are available on the backing class, like with get first name, get last name, or that could be additional properties that sort of access the target object and then like massage that into some different representation. You could go ahead and like with something like this add bean.call method and then hand the target in. So you basically still would try to limit the amount of stringly typed code that you have to write here. But you can actually invoke other Spring Beans to calculate values, enrich the representation if you want, right? It's not only about limiting stuff, it's also about like, you can also enrich your representations here. So what does that look like? Let's say the thing was called excerpt, right? Let's go to the customers, and take the first one and see that the address is like a complex object here, and we have this gender attribute in here, and we can then go ahead and say question mark projection equals excerpt, and we get the representation that's basically described by our interface, right? All this thing that the projection is actually available to a client is like exposed by using a URI template here. That's why the self link is included and a dedicated customer link, so that the client basically can detect, oh, I can actually apply a projection. And there's also ways to find out what values you can pipe in for that thing for a client. So we have created, and you can probably have a multitude of them, right? Different excerpt or projections for different views, for different scenarios. So the interesting thing now is that you can go ahead and declare one of these exceptions as so-called excerpt projections, which basically means, or what we're telling Spring Data REST is, whenever you actually point to the aggregate root that's managed here, the customer, we'd like you to include that a preview of that thing, and the preview looks basically like that interface described here. Right? That doesn't have any consequences if you just go to the customer. It just like continues to work. However, if we just look at the orders, we see that our order has now gotten an underscore embedded clause that hadn't been there before, right? And then it says, okay, there's an embedded, like a preview for what customer actually links to. So there's a connection between that customer, and you see there's some data in here. So if you see that your client actually needs that additional information, you basically shape a preview the way you need it, and then you can do a single call, say, give me all the orders, and it will include the name here. That would just work. And you can actually build a client in a way, and that's even proposed in the HAL specification, that basically implements a pattern like, okay, try to look up the thing in the underscore embedded clause. Like, let's say we are looking for a property called full name or something. We could try to find it in embedded customer full name. If it's not there, take this thing, resolve, fall back to the expensive resolution, and then try to find the property, right? With the gender attribute, that will work. Gender is not included here. That's bad, but we can still get it by getting to the customer. this thing here, right? It's still there. All right, projections. That's been it. They're supported like through all of in different parts of Spring Data. We've even moved them down to the repository level where we can use those projections to actually optimize the query execution and just only query for the things that you're asking for. But that's just the way they are applied in the REST world. So lookup types, an interesting concept. You've already, I guess, found yourself realizing that the concept of a JPA entity is not really matching, or not in all cases matching, what the domain-driven design entity actually is, right? And in some cases, it's even worse. There are things that in your domain could be modeled or should be modeled as value objects, have to become a JPA entity for a very weird reason, which is that you might want to control the overall set of available values. That's pretty cloudy, I guess, but remember I had this country property here, right? Let's assume we'll only be allowed to ship to a certain set of countries, and actually the country list is nothing but a list of strings, really. Right, so that's why I actually modeled it using Lombok's @value annotation. This is actually a value to my model. Right? It's just it doesn't have any identity. If I say Belgium, then I mean Belgium, Belgium, Belgium. Right. So the problem being, if I want to make this an extendable list that's managed via the database, I have to make it a JPA entity, right? Because I want to store the values that are available in the database. And even more so, I mean, I could go ahead and then and say, okay, I don't want to export or use a Spring Data repository for that, but just by I want to have like the convenience of Spring Data, and then I create a repository for that. And if I do so, let me check, or let's go to the API. I don't even have to change anything here. What does that look like now? Because Spring Data is kind of assuming that again, we have a repository for the thing, so it's assuming to be an aggregate root, which is not what we really want, because that means there's no string Belgium, for example, showing up here, like country Belgium, but there is a country link in here, and then to find that country again, I have to follow that link, and then I basically get my single property here, and like it's a full, like a top level resource even, right? As you can see here. Which is weird. So we can teach Spring Data REST to actually change that to what we call lookup types, which actually just requires a bit of configuration here. There's like it's like a value repository. That's the full value repository. There's a configuration option to change the way Spring Data looks up or creates the URIs and looks up the entities. And what we basically tell it here is say, okay, this repository is not really managing an aggregate. It's actually just a collection of simple values wrapped into a value type. We can actually get to the value that we want to display by calling getName. And on the other hand, because if we want to issue a put request to the server and then submit Belgium as string and not as a link, and we have to find a way to transfer that string into a value object instance again. That's why we hand in the method reference here. Actually, if anyone has seen, or if you have seen Brian Guts around, you definitely have to buy him a beer, because I was kind of surprised once more to see this is actually Java 6 API backing that kind of expression. Right? There's like type checks between those methods that this thing here takes a string as argument because that thing here returns a string. And we can write Java 6 based code in Spring Data REST because we need to be Java 6 based for the current generation, and still allow Java 8 users to write basically the configuration down like this. And it's actually type checking all the arguments, which is kind of, I'm still, forgive my surprise, but it's always kind of wow. Anyway, let me run or save this thing so that hopefully, or has it already restarted? Does that work? Did that work? It worked, because now we, instead of creating the bloody link, we actually got that thing inlined here. It's to the client. It just looks like an arbitrary value, but we can still go ahead and tweak the countries and change that name to, or not change it, but create new countries, remove other countries and whatnot. All right. Okay, value types. So 25 minutes left. That's good. Conditional requests, something that I just like to briefly touch on because it's overseen sometimes. And it's actually quite handy, because when it comes to the discussion of whether REST is suitable for what have you, microservices these days usually, then the question comes up with like, oh, it's so incredibly inefficient because you need to do a request and what have you. And the thing is, there's a lot of means in HTTP to actually improve on the fact that it's not optimized for efficiency, right? If you're really into efficiency, then a REST call compared to, let's say, a Google gRPC invocation is probably, yeah, on the downside. Really, it's not as efficient by definition. So the thing or there's a couple of means that HTTP implements, things like caching, cacheability, is deeply buried into the protocol, and conditional requests is something that people often oversee. What we do here to help you with that is the headers thing, is we inspect a couple of properties on your domain objects. That again ties into the story of, it's not the database that we expose, but we need or want to know certain things about your domain model. So for one, we actually detect that you're using an optimistic locking mechanism. See the @version attribute there. And there's also another thing that comes with Spring Data, is the ability to get the last modification date set by the Spring Data infrastructure. And that these are properties that, if like a casual Jackson, please render that thing, would just expose to your clients, right? But actually we can make better use of them, because there are certain concepts in HTTP that allow you to, or that have dedicated semantics, right? The last modification date is actually a well-defined header in HTTP. The version is actually a very suitable thing to use for an e-tag value, which is sort of like considered a hash over the entire representation, assuming you're still considering the aggregate root boundaries. But what that allows us, and what we're actually doing here, is that we return the appropriate headers. If you request a customer, we take that e-tag value and turn that into that version value, and turn that into an e-tag header, and the local date, last modified date field here is also turned into the appropriate header. What effect does that have? You can actually go ahead, and a client can actually go ahead and take a header, right? So let's say we're doing a first request here, right? We just like call customer/4711, and we expect the e-tag to be present and the last modification head to be present. And then we could do a thing as a client. We can go ahead and say, please, like I access the same URI, and then I add a header saying if non-match e-tag, right? So dear server, please only give me the customer representation if it doesn't match the version anymore. So if it had been updated by another client or what have you, right? And then it can actually give me back not modified. So it's not sending me that megabyte of JSON or what have you again, right? The same we can do for the last modified header. And so you can basically do, you can optimize on avoiding the representation being returned. And the other aspect of it that's not in the test case here, unfortunately, but you can also use that for conditional put requests. You can say, dear server, please only update that resource if it's still in version, if match, if it's still in version XYZ or what have you. Right? So you can actually use that stuff on the client, and just like works out of the box. There's nothing you have to do yourself in terms of tweaking Jackson, in terms of like rendering the header and what have you. Make use of that in a client. That's what I'm trying to say. All right. So for the time left, I'd like to give you an overview over the the integration of Spring Data REST into a more complex scenario where we want to build a RESTful web service that's actually, it's kind of a nice example because it's decently simple, but at the same time it covers a lot of ground that actually make the hypermedia aspect shine in that usually is a bit coming too short in the discussion, and also like implementing a couple of patterns that you will find when you're building RESTful web APIs nicely. So what is it about? We want to be able to order coffee, like in a Starbucks case or what have you. So imagine we want to build a Starbucks application where you can just like order your coffee up front and you just like go to that place and pick that thing up. So the thing, what we've modeled here is some kind of a state machine of the order, really. So we start by placing the order. It could be it will be in the state payment expected, and while it's in that state, I can actually update it. Right, I can add new line items to my order. I can realize that I don't have enough money on my, let's say, bank account or what have you. I can cancel the order. And the most important state transition actually is number 4, because that's basically me paying for the order at some point, which has a lot of consequences. The first one is that there's actually a background process running, which means that there is someone's going to go ahead and prepare my order. And the other thing is that I'm not allowed to cancel the order anymore, right? And that's actually a tricky thing to implement, or the question comes up, how do you implement that conditionality in the client really, right? So if you have a client that's not using any hypermedia at all, then it probably sort of has to detect in what kind of state the order is, and then just the question of when do I display the cancel button, right? When do I do that? Probably just like inspect the payload of the JSON quite closely and then do things. But we will get back to that in a second. The thing is, I've built an implementation of that service. Again, trying to use quite a bit of the Spring Data, Spring Boot, Spring Data REST stack, and it just like turned out nicely that we could actually separate two things from each other. One is the general handling of the orders, which pretty much follows like the very simple HTTP API in patterns that you see. Okay, we want to use a post to create an order. We want to use a patch or put request to update the order. We want to delete it to cancel it. So it's very much like we can just like use Spring Data for the repositories. There's not even a service layer that we have to implement here because the logic is so dramatically simple. On the other hand, handling the payments, there's like credit cards. There's a credit card validation going on. We actually need to trigger the preparation when a payment is triggered. And that needs quite a bit of manual implementation. We go ahead and do so. And then you see that slight shade of green, in that Spring Data REST box there, which means that we then use a couple of knobs and bells and whistles basically to let Spring Data REST or know about that other implementation, and then also tweak it to put in some guards, especially for the conditional requests here. All right, so. The first thing is that I decided to build the payment as totally separate endpoints, right? So I want to write Spring MVC controllers myself, and the question is, how do I do that with the Spring Data REST application? And it's pretty easy. You just do it, as you probably would have thought. What we see here, let me go here. There is in the order web package. There's a couple of things that we're going to look into in a bit. You've already seen an order projection, or already know what projections are. There's some event listeners, and there's a so-called resource processor. We'll have a look into that in a second. In the payment, on the payment side of things, there is basically a Spring MVC controller here. right? So it's just like, okay, we can receive a payment through a put request. When we actually receive that request, we issue the payment, and then there's like some asynchronous magic going on with like a thread blocking the order for a couple of seconds before it eventually frees it to simulate somebody doing something. Then we return that thing. There's some code in here where, as you can see, we have some APIs in actually a library that's independent of Spring Data REST. It's called Spring HEDIOS to actually ease the way you create links in those responses. I didn't spend too much time on that, but what you actually see with Spring Data REST out of the box already is a very, very intensive use of hypermedia elements, right? All these links pointing to each other. We use that API under the covers, but as you can see, you can also use them from your standard Spring MVC controller and what have you. Right, so there's like methods to look up the payment. We can take the receipt. In this case here, it's like /order/something/receipt, and then issue a delete request where we basically conclude the order. So this is like all the custom state transitions that stem from the fact that we can actually pay and what have you. So the question is just the crucial point here being you just write your controller with your custom logic, right? And then the question basically comes up, how do you actually integrate? I mean, as we've used all these hypermedia elements in our in the Spring Data REST representations, we like to add a link pointing to that new functionality, right? That's usually, I mean, that's the way you'd integrate those things with links. And the thing is that there's like a thing called a resource processor, which is just a one-method interface, really. That basically says, okay, whenever you render a resource for an order, right? So a single order, not like a collection of orders. Whenever you render a single order, please call that Spring Data REST. Please call that method. Here's the original resource, and then you can tweak that thing and actually return either something completely different. So you could actually go ahead and like plug in your own like object mapping there, but like introduce DTOs or what have you. But it's usually used to just like access the actual content of the resource and then add links to it, right? And that's what we do here. And here is basically the point where we implement that conditionality, right? We say, okay, if the order has not been paid yet, we actually add the payment link, and if it's ready, we actually add the receipt link here, right? And that's like what the client can then actually use, because you don't actually have to look at a certain field in the response to actually find out, oh, do I have to display the go to or checkout, the checkout button or the cancel button or what have you? You can actually, the client can just go ahead, is this link present? If that link is present, then I can actually display the cancel button. Right? Let's say, let's start with the other implementation. Actually, that's a good point to discuss that. The fact that we could only cancel the operation or the order when it was not paid yet, right? That's basically implemented here. If the order is not paid, then add a link with the cancel link relation. That has an interesting effect, because if you then go ahead and build a client in exactly that way, and say, okay, if I find the cancel link, then I display the cancel button so that the client can actually send the request to cancel the order. That actually has the interesting effect of that a business or a change in the business rule, that let's say we decide we can also cancel orders after the fact that it has been paid, right? We don't have to touch a single line of code in the client with that. We can just add the cancel link unconditionally, right? We could just move that up here and be done with it. If the client is written in a proper way, only inspecting the links and then finding that link, would still just like display the link saying cancel that thing. And we basically taught the client a new trick without even touching a single line of code on it. If you're interested in more in that stuff, there's like an article on my blog where I go into the nasty details of why I think hypermedia is quite an important thing, and especially in the context of microservices and evolving those. But, okay, this is basically the SPI where you can tweak the resource and add links to it. What else was there to discuss? Oh, there's like an event listener. Spring Data REST throws or publishes events for operations on the entity, right? So in this case here, we actually implement an event listener that wants to react on an attempt to delete an order, which basically plays into, if we went here, you see that cancel link or that cancel state transition. It was only allowed when the order wasn't paid yet, which means that we actually have to, for all other states, like for preparing, for ready, for completed, if someone tries to attempt to delete the order, we actually have to throw an exception and then basically return a method not allowed here in this case. Right? So basically implement the state machine in this case. I've shown you the order resource processor. That's basically everything that's necessary for integrating custom functionality. So we basically use the fundamental idea of that a link can virtually point to anything. You could even point to a different system. It doesn't even have to be the same system, right? Just implement the payment stuff in a different system. Why not? You just have to put a link into the resource that's actually pointing to that, and you can split them apart here. All right. So the question comes up. That's what I was trying to get to. The final thing I want to just like briefly touch on, because I'd like to take a couple of questions as well, is how do you actually document that kind of stuff, right? So especially if your the REST web services become a bit more complex, or actually become higher level web service, right? It's not only CRUD and HTTP, CRUD via HTTP anymore, but you actually provide business value through that API, and not just a glorified data access API via HTTP. Then the question comes up how you actually document these things. And what I've made use of here in this example is a library that that a colleague Andy Wilkinson is maintaining mostly, which is Spring REST Docs, which basically integrates, or the fundamental idea is that you write test cases to verify what your API does, right? And use those test cases to actually document what the API does, right? So that basically leading to the effect that you only, if your tests break, your documentation will not be generated, or to phrase it the other way around, you sort of have a guarantee that you document what's actually happening, right? So what you see here is an implementation of the order flow, basically. So we access the root resource, we create a new order, we then trigger the payment, we pull the order until it has been done, and then we take a receipt. And if we just go for create new order, you see there is a call to document in here, and we basically say, okay, we want to document that the step is called create order, and we want to document that we expect, when we create a new order, we expect a certain link being present, and that link is then pointing to the payment resource, and then that actually turning up to be a pointer to the next step, which is access first order. Where is it? Trigger payment. There's another thing here saying, okay, I want to document how to trigger the payment, and then have I need an amount, I need a credit card number, and once I'm done, I want to find a link pointing back to the order. That's basically just how it works. That in turn causes snippets to be generated snippets for my pay order flow down here. For the call request, the way the request looks, the way the response looks, and also there's like HTTP integration, just like a different HTTP client, basically. The one I've used before in the terminal. And then I have my piece of handwritten documentation in ASCII doc. And that then just basically includes the use cases ASCII doc, and that in turn includes like all the snippets, and if I'd taken this thing really seriously, so if I had to put it to production, I'd probably just like write a bit more prose than, oh, I can just like do this thing by following that link and what have you. I've set up this project to actually, when the test cases run, to actually produce the ASCII doc snippets in the first place, and then render the ASCII doctor into HTML, and then eventually make use of, I just render that HTML to a location that Spring Boot in turn serves by default, like for static resources, in fact, which then basically leads to the fact that I can use an aspect of the HAL browser. Let's get to that. I didn't mention that thing before. I think I briefly mentioned it. But once that's done, there's some Spring Data REST module that basically wraps a JavaScript application so that you can use that HAL browser here. That basically allows you to issue HTTP requests, but then knows about what HAL is and displays, you see that here, see that it discovers the links, right, and then sees that this thing has a title and shows that here. There's one thing about the HAL format that's quite important is the concept of so-called queries, which basically means that there's a well-defined name called queries that has a name property, and that's telling the client that every link that starts with that namespace actually, or there's documentation available for a link that starts with that namespace, and you can get to that documentation if you expand the URI template that's here, right? So we find documentation for the orders link relation under doc/index HTML anchor orders, which then means that you can actually go ahead and browse the payment the actual documentation with that. Something we put into the HAL browsers, or not into the HAL browser, something that you get with Spring Data REST actually out of the box is the ability to internationalize your links, right? The text for the links, enum values can be internationalized. You see, it had been German before, and because I use a German browser, or the local here is German, and if I switch that to English, then the server would return the internationalized values for that. It's just using a Spring resource bundle basically and a message source. But that's kind of helpful if you go so far and let the client just take these values that come with that thing and then use them in their UIs. Because if I just remove that again to see that back, so you get that for a German client, what have you. The other thing we do is that as Spring Data REST knows about, I told you all about the different, we know about the domain model and what have you. We actually expose a JSON schema for the structure, which we then use in our tiny extension here to, instead of displaying what the HAL browser would do normally, displaying just a plain form, we basically take the JSON schema, use another JavaScript library to generate a form from that thing. And then you can just like go ahead and use that form to actually interact with the API. The point here being is that there's like a complete package of us providing you support for also documenting that stuff, and then not just like documenting, and then it's your problem how to make that accessible. You can actually ship that with the API. You can just make it accessible through the system, right? The API is not really, the API is self-discoverable, but also you get just like human readable documentation, human interactable documentation here. All right, so with that, that's basically it from my side. Are there any questions so far? There's two in the front, one in the back. Let's start with you. Good question. The question was, what about security and access control? There is Spring Security integration. That it basically boils down to you using Spring Security annotations on the repository, and they will just be considered right? So if you want to prevent admins from looking, or somewhat non-admin from looking up certain things, you just like put in the Spring security expression. You can of course also go ahead and just use the URI-based security to just define your security rules, but. I see. So the question was about access control. That's what you put into so you want only users to be able to delete something that they have created themselves, right? You have to put that in the that into either the queries, like anyway. There's support for Spring Data integration with Spring Security for queries in the first place, and that then actually triggers the control of that. You still use the Spring security means basically that are available for that. Careful over there. One question and then I'll be done, I guess.
About projections.
Yeah.
How can I discover which projections are available as a client?
The question is, how do you discover what projections are available? The thing is that we are not only exposing JSON schema, but there's also there's a profile link relation that is a well-defined one where you can go ahead and just like query that thing and then go with RESTbox orders in this case, and by default it will return a description format. That's a pity. That's not working here. But by default it's going to return a description format called ALPS. Application level profile semantics, that basically describes which state transitions are available, and it will tell you that for the projection value there are these projections available. So because we have that knowledge on the server, we just expose it in an appropriate format for that. All right. I guess we have to take that question offline. Happy to answer it. Come by in a second. Thank you very much for attending. Sorry, I've overrun a bit. Thank you.